Okay, good morning everyone. Today we will start with centripetal force. We will complete our lesson. Okay, yesterday we talked about two important concepts which are centripetal acceleration and tangential speed. We started with tangential speed. We said every body moving in circular motion, it has a speed, okay, and to draw the velocity, the vector, we draw it always tangent to the circular path of this object, okay. And we said this velocity is changing every second because it's changing direction, because our body is not moving in a straight path, instead it's moving in circle. It means at every point in this path its direction is changing even though the speed is constant, okay. In the case the speed, which is the value of velocity, is constant, we say our circular motion is uniform circular motion, okay. So whatever, the velocity is always changing due to direction, okay. So since we have change in velocity, we said we have acceleration, because we know acceleration, it is a change in velocity in time. And this acceleration, we found its direction always toward the center, so we called it centripetal acceleration. Today we will talk about centripetal force, so pay attention with me. We know that we know that second law of Newton states that force equals ma. It means whenever you have acceleration, you must have force that causes this acceleration, okay. And you will see that this is the centripetal force we mean by it. This is the second law of Newton. F net equals to mass of our object times acceleration. So whenever we have an accelerating object, this acceleration, okay, is done because of a force, net force exerted on the object. So the force, we will give an example. It's here, okay. The string, we will have this example. Consider a ball of mass m that is being whirled in horizontal circular path of radius r, okay. So there is a ball here which is moving in circular path like this, okay. Let's study the forces exerted on this ball. This is the vector of the speed, okay. Here, focus with me, all of you, on this picture, on this one. So here the forces exerted on this mass are only two forces, which are the gravitational force, the weight of the ball, and the force of string, okay. The string, we have string here, the ball is attached to a string and it's moving in circular path, so the string here is holding the ball, okay. So the string is exerting a force on a ball to keep it from flying, right? So this we call force of a string, or if you remember, we call tension, okay. So now we will use this force of string, okay. These two forces, Fg, see, Fg is directly downward, and F string, it is along the string. So Fg is directly downward and F string is along the string. So F string and Fg, they are not along the same direction. If I want to add these two vectors in order to find F net, so our objective here, girls, is to find F net, because according to second law of Newton, F net is equal mass times acceleration. So the force that causes the acceleration is F net. So in this case, I want to find F net. Okay, in order to find F net, see, Fg, if you remember, girls, when we add vectors, we divide them into x component and y component, right? Then we add the x components alone and y components alone. Then we find the resultant. So you see here, Fg, it's along y, no problem with it. But F string, it's how along x and y, so I have to divide it into two components. One component along x, so see, we start from the tail, right? One component along x, so this is F string x the component of F string along X, and this is the component of F string along what? Along Y. So pay attention with me. So now instead of having F string which doesn't have a proper direction, we have these two, F string along X and F string along Y. So see girls, these forces, F string along X, F string along Y, and FG. Okay, we will add them in order to find what? F net. When we find F net, so we add this plus this plus this, right? And for sure we take into consideration what? The direction. So see, F string along Y is up and FG is down along Y. So these two, they cancel each other. They are equal and opposite forces. So still what we have? F string along X, the component of F string along X, so it is the net force. Okay, so again, net force, it's sum of forces, okay, acting on an object. So it's F string plus FG. F string, I need a proper direction for it, so I divide it into two components, one along X and one along Y. So I have now this F string X and F string Y, and FG, it's along Y, so no need to do anything with it. So we can see that these two forces are opposite and equal, so they cancel each other. So we get that F net here, it's caused by what, girls? It's caused by force of string along X. Okay, and we find its direction how? Like this. So its direction of F net, how is it going? It's going toward the center. So what do we call this force? This force F net, we call it centripetal force. So F net, okay, that causes the centripetal acceleration, it's called also centripetal force because its direction always directed toward the center. Okay, so in this case, in this example, when you have a ball attached to a string and you are moving it, you are moving it in a circle, what keep this ball in the circular path? Okay, it is the centripetal acceleration, which is caused by the string. Okay, so the force of the string here, it is the reason why the ball is moving in circular path, not in straight path, for sure. Okay, this is very logic. Why the ball is moving in circular path? Because of the string. So, and here we proved that. So in every example in our everyday life, for everybody moving in a circular motion, we must have a force that's pulling it toward the center, that's keeping it from going in a flat or in a straight path. Okay, so here the force exerted by the string has horizontal and vertical components. As we said, the vertical component is equal and opposite to Fg, thus the horizontal component is the net force because Fg and F string Y, they cancel each other. Centripetal force is simply the name given to net force on an object in uniform circular motion. Any type of force, so it may be one force or two forces give us the net force. Okay, so this centripetal force, it may be caused by one or more than two forces. So for example, now we will talk about like an example when we have a car, race car, moving in circular track. Let's see what is the force that keeps the car in circular path. Here you have motorcycle. A motorcycle, it's moving and like around a corner. Okay, so for this motorcycle to move in this circular path, we must have a centripetal force, we must have a net force that causes it to this motorcycle to accelerate, right? What is the type here, do you think, of this centripetal force? What girls here what keeps the motorcycle in this circular path and does not cause it to go out of the circular path? What is the type of force? What do you think? For sure it is the friction between the floor, the ground, and the tires. Okay, without this friction the motorcycle will not be able to turn around the corner. The motorcycle will go out of its circular path. So a motorcycle drives around a corner at a constant speed. Its direction changes for sure as it goes around the corner. So whenever any object goes in circle, its direction changes. So even though its speed is constant, it must be accelerating. This acceleration is due to change in direction. This acceleration must be at right angle, perpendicular to the direction of movement as it turns. For sure, we said the acceleration, it's directed toward the center, AC. Which way do you think the motorcycle is accelerating? Towards the inside of turn or away? So for sure toward. The motorcycle is moving, okay, around like in a corner. So and we said circular motion is any motion around a fixed center or axis, so inside. Okay, so here again, what is the type of circular? This acceleration, it's caused so by a centripetal force. The type of this centripetal force is the friction between the road and the tires. Without this friction, okay, the motorcycle cannot make this circular path. It will go out of the circular path as we said earlier. Now another example, we know, girls, that the moon moves around the earth. Type, what keeps the moon also in this circular path? Why the moon goes in circular path and doesn't go in a straight path here? Because there is something pulling it always toward the earth, so keeping it how in circular motion. So without this gravitational force, without this pull of gravity, the moon will go how? Will go in a straight path and continue its path like this. But because at every point the earth is pulling the moon because of the gravitational force, because of Fg, so the moon will not move like this. Instead it will move in its circular path around earth. Okay, so what is the type of what is the type of centripetal force here? What causes the centripetal force here? It is the gravitational force. Okay, so we have many examples. I will repeat again. So for anybody moving in circular path, we must have a force that pulls this body toward the center, that keeps this body on its circular path and doesn't cause it to go out of this circular path. So as another example, gravitational force is the centripetal force that keeps the moon in its orbit. Also another example, we know that the satellites, they move around earth. Okay, we have different types of satellites. Let's say monitoring satellites, okay, weather satellites. So satellites orbiting earth are held also in their circular path. They have exact circular path. They can't go out of it. Okay, so they must move on this circular path around the earth. So what causes this circular path is the centripetal force. So centripetal, what is the type of centripetal force here? Is also the gravity of earth. Okay, so Newton's second law can be combined. Now I want, girls, what the equation of centripetal force. Okay, so centripetal force, we already said it is ma, right? It is net force. Centripetal force, it is the net force that causes this acceleration. So Fc is equal to mac. So this c, this subscript, it means centripetal. And we already know that the acceleration, centripetal acceleration, its equation is Vt squared over r. Combine these two together. So replace acceleration centripetal by its formula. You will get centripetal force equals mvt squared over r. So this is the equation of centripetal force that we will use in this lesson. Okay, so let's say here the last part for today, that also you are moving a ball which is attached to a string. Let's say that the string here at a specific position, it breaks. So what will happen for the ball if you are moving it like this? Okay, so the ball at this, look girls, at this position exactly, the centripetal force has gone. So the centripetal force here, it's not now present. Okay, so the ball, will it continue in circular path? No, because the centripetal force is no longer present. So it will go how? In a straight path upward. Okay, did you get it? So another position, if you are moving the ball like this, okay, and at this point, for example, the string breaks. So here the ball will what? Will not stay in circular path because the force that keeps it in circular path has gone. So the ball will go how? Straight forward, but because of gravity, then it will go toward the ground. Okay, it will go first straight forward like this in a straight path, but because gravity here is pulling it, then it will go down. Okay, so if centripetal force vanishes, the object stops moving in circular path. No circular path anymore. So a ball that's on the end of string is whirled in vertical circular path. If the string breaks at the position shown in part A, the ball will move vertically upward. Then for sure it will not stay upward forever. It will then fall toward earth because of gravity. If the string breaks at the top of the ball's path, as in part B, the ball will move along a parabolic path. At the beginning it will move straight forward, but because of the gravity it will then go down, so we say it's moving in parabolic path. So you can see this example. This woman is moving this ball in a horizontal path, in a horizontal circular motion. So if here the string breaks, the string released. If the string released when the ball here, the ball goes straight toward A and not toward B. Okay, the ball can't move anymore in a circular path because the force responsible for this circular path has gone, so it will move in straight like this. Then it will fall for sure. Okay, so again the last slide for today. So what is centripetal force? Centripetal force, its role is to maintain the motion in circle. Okay, it can be produced in different ways depending on the example we have. Gravity, like for example for the example of moon orbiting earth or satellite orbiting earth, so the type of centripetal force in this case is gravity. In the case of ball attached to a string, the type of centripetal force is the force of string. In the case of a car moving in a corner, or motorcycle moving corner, the type of centripetal force that keep this motion is friction. Okay, which way will an object move if centripetal force is removed? As we said, in a straight line as shown to the right. Okay, so this is everything for today. Thank you, girls.